Hi, this is Chris with Sanderson Test Prep, and we are taking a look at questions 13 and 14 in section 4 of SAT Practice Test 1. So let's take a look at 13. We see a table, and the question reads, a group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data are broken down as shown in the table above. Which of the following categories accounts for approximately 19% of all the survey respondents? So first we have to ask ourselves, how do you calculate a percent? And I'll put that formula over here, but percent can be calculated as part over whole, which will give you the decimal version, and then to convert it into a percent, it's times 100. So this is a formula that we should absolutely know. So it's part over whole times 100 to give us our percent. So we're going to just start going through our answer choices and taking a look at each category and checking to see which one comes out to be approximately 19%. So it's okay if it comes out to maybe 18.9 or 19.1, but we're just looking for what's approximately 19%. And luckily, this is a calculator section because some of the numbers here are pretty large and you wouldn't want to have to do those manually if you can help it. So this is a question that we are very happy to see in the calculator section to make our lives a little bit easier. All right, let's check it out. Females taking geometry. So if we look at our table, we look at females and we look across to geometry, that will be 53. And it says of all, so out of all participants, which means our grand total, which is 310. So if we do 53 over 310 and then times 100, let's see what that gives us. That's 17%, comes out to about 17.1%. So that's going to be approximately 17% for this. Now, is that approximately 19%? I don't think so. But do we know for sure? Not yet, because with an approximately question, you're going to be picking the answer choice that's closest. And right now, we don't have enough information to know whether or not there's anything else that's going to be even closer than 17%. So for now, we can potentially leave A on the table and go ahead and continue with our calculations for the rest. So here, let's take a look at answer choice B. Females taking algebra 2. So here, that would be females, algebra 2, 62 out of 310. And if we calculate that as a percentage, that comes out to be 20% exactly. So now we can eliminate A because 20 is closer to 19. So 20, maybe that's our approximately 19 number that they were looking for. Although if it did come out to be 20 exactly, my guess would be the way that the test makers would write the question, they would just take out approximately and they would put in 20 here and ask you for the exact value if it does come out to be exact. So again, my instinct is that I don't think that's going to be it, but for the moment we don't have any more information than to say that, hey, B so far is pretty close to 19. Let's continue our calculations. So let's take out that 62 and let's look at the next category. So here it says males taking geometry. So males go across to geometry, that's 59 out of 310. And let's do that calculation and see what we get. And that comes out to 19. It's like 19.03%. So again, now we are even closer. And I think that's probably going to be it just because that's very close to 19. It's off by just a tiny, tiny little decimal. But just to be doubly sure, let's do one last calculation here. And let's make sure if we do males taking algebra 1, so that would be 44. And if we do 44 out of 310, let's see if we get something that is even closer, or 19 on the dot, and we don't. That comes out to 14.2%. So that's not it. We can say confidently that it is answer choice C, and just to rewrite that calculation, that's going to be 59 over 310, and that comes out to 19, and that's our answer here. So the main takeaway is that whenever you're dealing with percents, you want to know how to calculate that, and that's going to be part over whole times 100. Moving on to question 14. So here we have another table, and the question reads, the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? So first of all, let's just talk briefly about the definition of this term outlier. So when they say outlier, in statistics, they're referring to a number that doesn't seem to go with the trend in the data. Oftentimes, an outlier is either a unique data point that was an actual data point, but it just happened to be very unique. So for example, if you were to look at a bunch of test scores for a student, you might see a student have a 92, 88, 85, 93, and then if a student had a 20 on a test, that would seem like an outlier to that data. And it could be real, because maybe a student just didn't prepare, they had a rough week one week, they forgot that there was going to be a test, whatever the situation was, and that outlier data point was an actual data point. And then sometimes outliers can be mistakes. So for example, if you were looking in a teacher's grade book for a student, and a teacher was typing, let's say, grades into a spreadsheet or something like that, and you had 92, 98, 93, 95, 100, 96, 100, 97, and then 1,000. So that one likely would be a mistake. Maybe a student actually got 100, and when the teacher was typing in the grade, the teacher accidentally typed in an extra 0. So sometimes outliers are real data points, sometimes it's because of a mistake, but either way, it's something that doesn't fit with the trend in the data. So when you see that term outlier, that's what that means here. So here they're saying that 24 is an outlier, and if you look, it kind of is, because every other data point, they're listed in order, and they increase in increments of 1. You're going 8, 9, 10, 11, so forth. And then all of a sudden it jumps by 8 when you go from 16 to 24. So that one does seem like it's unusually high compared to the other data points. Okay, so now we have to test these different values, mean, median, and range, and see which one will change the most. So what I recommend doing on these questions, so that you don't have to do exact calculations for everything, because mean here, even in a calculator section, to calculate the mean or the average, you would have to add them all up, which means even with your calculator, you're still typing in 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 plus 11 plus 12, and so forth. And then dividing it all by 21, and then taking out the 24, and then doing it again. So that's a fair amount of calculation that we would have to do to find the exact value of the mean before and after removing that data point. Let's see if we can avoid having to do that. So let's take a look at our data points here. We have mean, median, and range, and we want to see what's going to change the most. So here, whatever it is that's changing by 24, remember that that change is, you're going to have all these numbers, right? So data point 1, 2, 3, 4, 5, all the way, right? All 21 of those data points all the way along, and then plus 24. But remember that that whole total, when you're talking about your mean, is being divided by 21. So even if you take out the 24, and then now you're only dividing by 20, that's still going to institute a relatively small change. Your mean is going to be affected minimally by removing one data point out of 21 data points. It will change. It will have some value to it, but your mean is going to have a very small change when you remove just one data point out of that many data points. So for the mean, we can expect a small change. Now let's take a look at median. Median just means the middle number. So here, for median, whenever you see median, I want you to just think middle. Median is middle. So our middle number currently is 12, if we include the 24. And then when we remove the 24, that's going to change our middle value. So if we take the 24 out, and now instead of this 12 being right in the middle, there are going to be two numbers in the middle because you have an even number of data points. And it's the same thing. I'll put a little example over here, but if you had 1, 2, 3, then 2 is clearly the middle number. But if you had a fourth data point, if you have 1, 2, 3, 4, now your middle, there's actually 2 numbers in the middle, and to calculate your median, you would have to average those, which means it would be in between those values. It would be 2.5. So that's the way that median works. So here, this 12 was our original, but our middle 2 numbers, and you don't have to write them out. You don't have to worry about, wait, is it going to be these 2 here? Or, wait, hold on, is it these 2 here? Either way, both of the values that are going to be your 2 middle terms now, they're both going to be 12, which means there's no change to the median. So the mean has a small change. The median, that change will be 0. And then let's check the range. How do we calculate range? So hopefully, if we remember, our range is going to be our largest value minus our smallest value from a data set. So here, 24 minus 8, your range would be 16. And then if we take out that 24, so when we do that and look at our new largest value of 16, now you do 16 minus 8, which would be 8 for the new range. Our range, you can tell, is adjusted by a lot, right? It goes from 16 to 8, so our range is changing by a value of 8, and they wanted to know which one would change the most. So of these 3, the range is by far going to be the largest change, and if you're able to answer this question without having to calculate the exact mean before and after removal of that outlier, then you're saving a little bit of time, which is always key on test day. Stay tuned and we'll continue with the rest of the multiple choice.